So here we are, Algebra 2 with trig, doing our geometry unit of special right triangles. The first portion of this is a 45, 45, 90 triangle. A 45, 45, 90 triangle obviously has two angles that are the same. So that is going to also be an isosceles triangle. So you're going to have two sides the same. If you have a right triangle that has two sides the same, you're guaranteed to have two angles the same. And the only way to add up to 180 degrees is for both of those angles to be 45. So an isosceles right triangle is going to always be a 45, 45, 90. So working with a 45, 45, 90 triangle, we have a formula we can use, that the hypotenuse is always the leg times root 2. Leg root 2 is the formula for calculating the hypotenuse. So in our first example down here, we're told that we have a 45-degree angle, we have a 90-degree angle. So we know to add up to 180, this angle has to be 45. So yes, we have a 45, 45, 90 triangle. The leg, which are the perpendicular sides, they are going to be the same in a 45, 45, 90 triangle. So this side would be 12 also. And the hypotenuse, using our formula, hypotenuse equals the leg times root 2. The hypotenuse is going to be 12 times root 2. So by using the formula, we can calculate for the missing side. We only have one formula to use in a 45, 45, 90 triangle. Now, if we know these are both 12s, we could use Pythagorean theorem. That would work. Okay, 12 squared plus 12 squared equals a hypotenuse squared. And you would start to bring those together, and you would simplify your radical, and it would come down to 12 root 2. But this is by far faster. So you want to use this on an SAT format. So here we see we have a right triangle. We know two legs, the perpendicular sides, are the same measurement. So we know that the two angles have to be the same. Those two angles would both have to be 45 for the triangle to add up to 180. So this is a 45, 45, 90 triangle. So the hypotenuse is going to be the leg times root 2. The leg is 10 root 2, and we're timesing it by root 2. So you need to be sure to show your work for some of these more complicated ones for sure. There's a couple different things you can do here. We could say the like terms, the radicals, the root 2 and root 2, those would multiply each other. So if you wanted to, you could call that root 4. But of course, root 4 is just a value of 2. So when you take root 2 times root 2, you'll get 2. Just like if you took root 3 times root 3, you'll get 3. Or root 8 times root 8 is 8. When you square a square root, you get the number that's inside. So this will come out to be 20. So the hypotenuse is 20. That is the leg times root 2. Same idea for this last example. We have a right angle. We have two legs that are the same. So yes, it's a 45, 45, 90 triangle. So the hypotenuse is going to equal the leg times root 2. So to calculate, we want to multiply that leg by root 2, which is going to give us 4 times 2, because root 2 times root 2 is 2, which equals 8. So that was finding the hypotenuse each time. Now we can go and find the leg. Makes it a little bit trickier. We still use the same formula. The formula is still the hypotenuse equals the leg times √2. So that keeps it simple. We have 15 √2 as the hypotenuse, because remember, the hypotenuse is always across from the 90. So that's going to be your hypotenuse. These are going to be your legs of the right triangle. So x is a leg, and it is supposed to multiply √2 to make the hypotenuse. Now they're equal to each other. So to get the x by itself, we're going to divide by √2. By dividing by √2, the radical goes away. And it'll go away on the other side also, because it's 15 times √2 divided by √2. The radicals cross out. So of course, the leg has to be x. All right, the hardest one, maybe on the entire page, is this next one. It's still the hypotenuse equals the leg √2, because it is a 45, 45, 90 triangle, because the legs are the same length and it's a right triangle. The hypotenuse is 9, the leg is x, and the leg is being multiplied by √2, so it equals the hypotenuse. Just like before, if we want to get the x by itself, we need to divide by √2. That's going to cross the √2s out. That leaves us with 9 divided by √2. Now what we're going to have to do is rationalize the denominator. That means we have to get the radical out of the denominator. If we were looking for the decimal version, we could do 9 divided by √2. That's the exact answer in terms. Decimals are not exact, but that is the answer. But to leave it in a simplified radical form, it's not simplified correctly if the radical is in the denominator. We can't have a radical live in the denominator. So to get rid of that, when you multiply a radical by itself, the radicals cross out and you get the value of 2. But whatever you do to the bottom, you have to do to the top, because now we're multiplying that original fraction by a value of 1. And we all know that if you multiply a fraction by 1 or any number by 1, you don't change its actual value. So 9 divided by √2 times 1. In this case, it's going to be 9 √2 over 2. That is what each of these legs would be. We would not simplify that down to 4.5 √2. Don't turn that into a decimal. That is called simplified radical form. All right, this next one. The hypotenuse equals the leg times √2. Because it's a 45, 45, 90 triangle, and we know that because it's a right angle with 2 legs the same length, so it has to be 45, 45, 90. So we're going to use our 45, 45, 90 rule, which is hypotenuse equals leg √2. The hypotenuse is across from the 90, so that is the 12 √2. The leg are the 2 perpendicular sides, so that's x √2. And yes, we would divide by root 2 and divide the same thing to the other side. They cross out. So we get a value of x. So now you can pause the video, you can try the next 3 questions, and then you can run it and you can see how you did. To run over these problems, we know that the hypotenuse is going to equal the leg root 2. We know this is a 45, 45, 90 triangle because it's 90 degrees with 2 legs, the same measurement. You have to identify that this is in fact a 45, 45. Don't assume. You have to be able to identify it. So we talk about it each time. So the hypotenuse, which is across from the 90, is 2 root 2. The leg is x, root 2. We would divide by root 2 to get the x by itself, and x would have to be 2. Same idea again. We're looking for the hypotenuse, so that'll be called y. The leg is root 2. We're timesing it by root 2. All right, they're not all the same just because there's a root 2 involved. It's still root 2 times root 2, which is the square root of 4, which is known as 2. When you square root, you get the number that's inside. All right, now this is like a square, like the tiles that are on the ground. The diagonal between the tiles on the ground is being somewhat represented by this picture. The tiles on the ground are much closer to 12-inch tiles. This happens to be 8, but the diagonal can still be calculated. It clearly is not 8 because it's not 60, 60, 60. If the angles were all 60, then they would all have the same side length. But this has a 90-degree angle, so the hypotenuse is going to be the longest. So we're looking at just this part of the figure, which is the right triangle. It's an isosceles right triangle. And the hypotenuse is the side across from the right angle. So the hypotenuse is going to equal the leg times root 2. So the hypotenuse is considered D in this case. The leg is 8 times root 2. So D is 8 root 2. No decimal version. All right, on the flip side, we're going to start talking about the 30, 60, 90 triangle. It's another special type of triangle that we can memorize the multiplication between the legs. There's just 2 types that we memorize, the 45, 45, 90 and the 30, 60, 90. So across from a 30-degree angle would be considered a short leg. The shorter leg will always be across from the smaller angle. The longer leg will always be across from the longer or larger angle, which is 60. Across from the 60 is the long leg. And the biggest angle across from it will be the biggest side, which is always, as long as it's a right angle, is called the hypotenuse, HYP. So their relationships is the hypotenuse is 2 times the short leg. The hypotenuse will always be twice as long as the short leg. The long leg will be the short leg times root 3. Now you've got something you've got to remember. It's root 2 for 45, 45, 90, but it's root 3 working with the 30, 60, 90. There's different ways you can remember that. There's 3 different angle values, so it's root 3. Two angles are the same in the 45, 45, so it's a root 2. However game you want to play, this has a 30 in it, so you remember that this will have a 3 in it for the radical. So our first example, they're giving us the side that is across from the 60. So this is considered the long leg. Across from the 30 is considered the short leg. And across from the 90 is considered the hypotenuse. So you first need to identify what sides you have. What side are you working with? You're working with the long leg. So you're going to probably use the formula that is long leg equals short leg times root 3. The long leg is your 9 root 3. The short leg is the x value, and you have to multiply that to root 3 for it to be equal. Now it's equal. 9 root 3 equals something root 3. That makes some sense. Since we divide out the root 3, the root 3's themselves will cross out, and we'll be left with x equaling 9. If the short leg is 9, then the long leg is going to be 9 root 3. That makes sense. And to calculate the hypotenuse, which is the short leg times 2, the hypotenuse is y, the short leg is 9 times 2, so you get 18. 9 times 2 is 18. And there you have solved, because you know all 3 angles and all 3 sides of the right triangle. You solved the right triangle. This one here is probably as tough as it can get. So if you understand this one, then you understand them all. Across from the larger angle is going to be the long leg. Across from the 30 is going to be the short leg. And across from the 90 is going to be the hypotenuse. So you should identify what side you're being given. So we've been given the long leg. So the formula is long leg equals short leg times root 3. The long leg is 15. The short leg is a root 3. So just like before, to get the a by itself, we are going to divide by root 3. Now we know what a equals. By crossing off the root 3, you have the a by itself. Now you have 15 divided by root 3. Some people look at that and they say, oh, 15 divided by 3 is 5. So is that root 5? No, it doesn't quite work like that. Okay. So we cannot simplify that the way it stands, but we can rationalize the denominator. To rationalize the denominator, you take the 15 over root 3, you multiply it by root 3 over root 3 to get the radical out of the denominator. We're multiplying that fraction by a value of 1. So we get 3 on the bottom, we get 15 root 3 on top. And we feel like we're all set. No, you cannot cross out the 3's because 3 is not the same thing as root 3. Right? Root 3 is something times something that makes 3. But you can reduce the 15 and the 3 since they're both whole numbers. So your long leg is actually your short leg, your A value. Your A value is 5√3. And then to find the hypotenuse, we use our formula. Hypotenuse equals the short leg times 2. The hypotenuse, which is the letter B in this case, equals 5√3 times 2. You do not take the 2 and times the √3. You take the 2 and you times the 5. So the B value is going to equal 10√3. Now you can work on the U try, and you can come back and you can check your answers. So we'll go on and try these practice problems. We see that the long leg is across from the 60, the short leg is across from the 30, so the hypotenuse is across from the 90. So they gave us the long leg. That means we have to use the formula that has the long leg in it. The long leg times √3. So we have 8 times x √3. So we're going to have to divide by √3 to get the x, the unknown, by itself. So we're going to take the 8 divided by √3, and we will rationalize the denominator. So that leaves us with 8√3 over 3. That does not reduce. We do not turn that into a decimal. No calculators. So let's see, we solved for x, and x is the short leg. So this is your 8√3 over 3. So now we'll take the hypotenuse, which is the short leg, times 2. The hypotenuse is the letter y. The short leg is 8√3 over 3 times 2. So here we have a fraction times a whole number. So some people make the mistake and they multiply the top and the bottom, but then that's reducible. So don't forget, a lot of times people like to show that there's a 1 underneath that fraction that helps you remember. You multiply the tops together, you multiply the bottoms together. So this is going to become 16√3 over 3. That is not reducible either. Then we come over here to our last one. Because there's only one side given to us, we can't use Pythagorean theorem. We can't do leg squared plus leg squared equals hypotenuse squared. We don't have enough information. So that's the advantage of knowing your 30, 60, 90 rules. So we're given the short leg, we're looking for the long leg, and we're also looking for the hypotenuse. Doesn't matter which one you solve for. The long leg is the short leg times √3. The long leg is x, the short leg is √3, and you're timesing it by √3. When you multiply √3 times √3, you get the 3. That doesn't change. And then the hypotenuse is simply the short leg times 2. So the hypotenuse, which is y, equals √3 times 2, which is going to be 2√3. We typically write the integer in front of the radical, not after it. Questions about that? All right. So when we look here at example number 5, seems kind of tough. They want to know the height. You know that height has to be perpendicular to something. That's what makes it a height. So when we look here, the height is the value going up and down. It is perpendicular. It's 90 degrees to another side that we often call the base. So it wouldn't matter if it was turned sideways. That would still be considered the height. It's perpendicular to one of the sides. But when I look at this question, I don't see any angle values. It kind of looks 30, 60, 90, each one of those smaller triangles, but it's not drawn in there. So your first instinct might be, I don't know what the angles are. So you could get away, actually, with looking at just one of those triangles. And you see that you have 4 for the hypotenuse, because that's across from the 90, and you have 2 for the other side. Notice how that length is 4, this length is 4, and this total length is 4. Because they're all the same length, you know that it's an equilateral triangle, which makes it a 60, 60, 60 for the angles also. And if that's 90 and that's 60, this has to be 30, which makes this have to be 30. That's one way you could do it. So yes, this is actually a 30, 60, 90 triangle. You didn't even have to know all that stuff. You could have done Pythagorean Theorem for this. Hypotenuse squared equals leg squared plus leg squared. Hypotenuse squared would be 16 equals 4 plus the other side squared. Subtract it, you get 12 equals the other side squared. Take the square root of 12. So take the square root of 4, which is 2. So 2 root 3 is our answer, if you do it the Pythagorean theorem way. Or you notice it's a 30, 60, 90 triangle, and the height is going to be the short leg times root 3. You don't have to do Pythagorean theorem at all. You just take the short leg, because this has to be a 30, 60, 90 triangle. That's the key. It has to be a 30, 60, 90 triangle. The next step to this question is to ask, what is the area of the big triangle? You need the height. We found that. You know the base. So area of a triangle is half of the base times the height. So you have enough information to do that. But they're only asking for the height. Okay, number 6. Alex has a team logo patch in the shape of an equilateral triangle. So something like that, which we know means that all 3 sides are the same, which requires all 3 angles to be the same. If the sides are 2.5, so 2.5, what is the height of the patch? So the height of the patch, if this angle here is 60, and that's 90. This has to be 30. This is 2.5. So we know that the short leg is half of the hypotenuse. So this would be 1.25. And the long leg is going to be 1.25 times root 3. If you don't like the decimal idea, 1.25 is the same thing as 5/4. It's fourths because it's quarters. Has to be an extra fourth. There's 1 1/4. So 5/4 would give us that. The decimal kind of follows along. Since I started with a decimal, that's how we had a decimal in our answer. Okay, the last two questions here. You could try these. We know again that this is 12, 12, and 12 total. So you know this is a 30, 60, 90 triangle. So you know the height is going to be 6 root 3. It's the short leg times root 3 to get to the long leg. Kind of doing those in a fast fashion, right? Here, we could say that the long leg equals the short leg times root 3. It's good to show some work. So the long leg is x. The short leg is 2 root 3 times root 3. That's going to be 2 times 3. So the long leg is going to be 6.